Hello, my name is Andrei Kulikov, and in this video I'd like to continue exploration of XGBoost tutorial part 2. So next part is prediction options. So when I want to predict something, here are various parameters that can be put. So let's check them. So I load my data set, put some parameters for training and then training and make prediction without any parameters. And if I put of them the result will change. So first parameter is output margin. It shows whether to output the raw untransformed margin value. It is used with strict shape true. So the result became in some other format. So next is pred leave true and pred contribs. They are used for shaping, also with strict shape true. The results have such a view. So pred contribs another view. Yes. Very beautiful. Maybe in future I'll use it. I don't know. So can we put the entry limit in integer? It is deprecated and must be used iteration range instead. Okay. Approx contribs approximate the contributions of each feature used when pred contribs or pred interactions are set to true. Changing the default of this parameter is not recommended, so don't use it. Very complex view. Okay. Pred interactions. When this is true, the output will be a matrix of size and sample fits indicating the shape interaction values for each pair of features. Very interesting. So I use it and get the following. Wonderful. Validate features. When this is true, validate that the boosters and the data's feature names are identical. Okay, nothing changed, but it may be useful. Training boolean, whether the prediction value is used for training. This can affect dot booster, which performs dropout during training interactions, but use all trees for inference. May be useful. Let's remember. Training true. It also can be used when there is few data. Okay, interaction range specifies which layer of trees are used in prediction. For example, if a random forest is trained with 100 rounds, specifying iteration range 10-20, then only the forests built during 10-20 rounds are used in this prediction. Okay, here nothing will change, of course. Strict shape boolean, when set is to true, output shape is invariant to whether classification is used. For both value and margin prediction, the output shape is not used. Equal 1 when multi-class is not used. Okay, default to false, in which case the output shape can be if multi-class is not used. Okay, maybe I'll need it in future. Okay, early stopping. A model that has been trained or loaded can perform predictions on data sets. If early stopping is enabled during training, you can get predictions from the best iteration with best iteration. Okay, if you have a validation set, you can use early stopping to find the optimal number of boosting rounds. Early stopping requires at least one setting evils. If there is more than one, it will use the last. So here it is, and one unknown for me thing now, it gives me that the matrix is not iterable, but it used the matrix. Okay, maybe in future I'll find out the secret of it. So there are two predictors in XGBoost, namely CPU and GPU predictor. The default option is altered so that XGBoost can employ some heuristics for saving GPU memory during training. They might have slight different outputs due to floating point errors. Okay. Base margin. There is a training parameter in XGBoost called base score, and the metadata for the matrix called base margin, which can be set in the fit method if you are using scikit-learn interface. Okay, this specifies the global bias for boosted model. If the latter is supplied, then former is ignored. And base margin can be used to train XGBoost model based on other models. See demos on boosting from predictions. Okay, for me it's a secret what is margin, but I'll check it later. Okay, stage prediction using the native interface with the matrix prediction can be staged or cached. In place prediction with no use of the matrix since is slow and memory consuming. Uh, in place predict. So I used it, it worked wonderful. Categorical data other than users performing encoding. I used it in my previous video, and in the next video concerning this concerning benefits of PyXL topic, I'll use my I'll show my problems with categorical data and its encoding with the feature of XGBoost. Some problems I had, maybe connected with this one or not, I don't know, but I solved them. Okay, second, tree methods. Tree methods. So where am I? I'm here. For training boosted tree models, there are two parameters used for choosing algorithms, namely update and tree method. Okay, XGBoost has four built-in methods, namely exact, approx, hist, and GPU hist. Along with these three methods, there are also some freestanding updaters, including refresh, prune, and sync. So exact solution, it's a vanilla gradient boosting tree algorithm. During each split finding procedure, it iterates over all entries of input data. Exact, all entries. It is more accurate among other grid methods but slow in computation performance. So params tree method, and let's go. So and I train and get the same results. So some other solutions I can use here. It's approx, hist, and GPU hist. Approx, it runs sketching before building each tree using all the rows belonging to the root. Hessian used as weights during sketch. Okay. The fastest histogram hist. The fastest an approximation tree method used in light OGBM with slight differences in implementation. It runs sketching before training using only user-provided weights instead of Hessian. Wonderful. The subsequent per node histogram is built upon this global sketch. GPU hist with GPU. So some objectives like rect squared arrow have constant Hessian. In this case, hist and or GPU hist should be preferred as weighted sketching doesn't make sense with constant weights. When using non-constant Hessian objectives, sometimes the prox yields better accuracy but with slower computation performance. As for all of these parameters, it's a dark side of machine learning, and only experiments with them can give a result and some ex experience with experiments. So other updaters, prune, refresh, and sync. Uh, um, with this set of parameters, process type update, prune, update, refresh. Ah, process type update, refresh. Process type update, prune. During training, XGBoost will prune the existing trees according to two parameters: min split loss and max depth. Okay, with the refresh, the statistics will build trees on a new training dataset. When refresh leaf is also set to true, default XGBoost will update the leaf value according to the new leaf weight, but the tree structure split condition itself doesn't change. And sync synchronize the tree among workers when running distributed training ad. Okay. Feature matrix, so following tables summarize some differences in supported features between four tree methods. Feature parameters that are not mentioned here are universally supported for all four tree methods. So, for example, for categorical data cannot be used exact method, and exact cannot be used for many of them. Okay, next stage parts, Python package. Python package, here is the documentation, and it has many contents for this, but they are nearly the same. Okay, so what I have here, I can ask, I have my model, and I can ask attributes of it. I can ask, for example, for best iteration it is 49. Can this should be called directly by users? I can copy. I had already this. Okay, I can check files. The different. I can dump the model in text format. I did it here somewhere. It is text format. Okay. So I can eval. So model evaluation is the process through. It is very important. Is the process through which we quantify the quality of. It's like experience and experiments, and the quality of quantity of the quality. To do this, we measure the newly trained model performance on a new and independent data set. This model will compare labeled data with its own predictions. The result m log loss is chosen by objective. I suppose I used some material here. Ah, okay. And okay, it's for multi-class classification. It's my task to check it, to try this. It is very small, very small. Model evaluate predicts values and calculates losses and all attached metrics to the model for a given data set. It returns a list containing losses and indicators in one value. Model only predicts the output of the model, taking into account the input data from the dataset. The inner workings of model predict are used inside the model evaluate, but the result is different for both because they don't calculate the same thing. So here is dot 15. Make an empty list. Why did I do this? Ah, I I tried to use able set, but if I use this one, it will give sorry. If I use an empty list, it will give me 0. But if I use my Dmatrix, it will give me, and if I use yes, iterable, and if I use X train, for example, it will be. I don't think that it will be something good. Expected Dmatrix. So okay, let's go further. So I can ask for feature names, but it's empty. I can ask for feature types also empty in my case. Okay, I can get dump. Maybe if somebody will need it. I can get F score for each feature. I can uh, get score with importance type. I can uh, importance type. Okay, gain, weight, cover, and total gain and total cover. I can split. Am I going? Yes, I can split and see some information of my um, feature and its target value, some cardinalities, and I can run prediction in place. It doesn't cache the prediction result. Okay, maybe it is used. I can, of course, save config. I can load config. I can ask for this model in my code and watch it here. So I load it from my JSON file and save again for some experiment, and can see my num boosted rounds. It's it is the same as, come on, iteration, best and tree limit. It's the same. Okay, limit. That's why they're the same, because the limit is 50. So now features, I can say save it in a row. Maybe I'll use it. Very beautiful. Okay, uh, so I can set params into the booster. Yes. Okay, and Maybe I can do this command and see the parameters of my model in a more convenient way. It's a good thing. Yes. So I can update for one iteration with objective function calculated internally. This function shouldn't be called directly by users. Okay. So next part is learning API. So it's a very large material here. So I can use params and I can, while training, and I can use some other given parameters. Here are they. Many of them: early stopping, verbalizables, XG model to be loaded before training. uh, Allows, oh, cool thing. You can load and then continually train your existing model. It's a good thing, yes, because some new data can appear, and it increases the quality of the model. XGB model, let's remember. So callbacks and the metrics, custom metric. I used it in the previous video, as far as I remember. Yes, okay. It was before. And also I can use CV, so cross validation with some params. Here are they, many of them. Okay, thank you. Thank you, Internet, for this site. So I can plot my model to see some results. Beautiful thing with the plot tree, with plot importance, graph wiz can be used. So, and next part is Skylight's Learn API. It's this one, Learn API, where I can use it in different in SkyKit. So I use it in SkyKit because it can be used for my categorization task, where it's true. So here it is. As for Skylearn, must be used 2 stars here when I put params. Without it, it works incorrectly. Um, so I trained with XGB classifier my model again. Received something. What's that? Okay. The length of my data. Return. No, not data. Return the predicted leaf every tree for each sample. If the model is trained with early stopping, the best iteration is used automatically. So what's apply? Apply. Okay. Apply is apply. Why didn't I write the description? So apply, return the predicted leaf every tree for each sample. Yes. Okay. Fine. So best iteration again, 99 and the 50. Okay. So is only defined when early stopping is used, so it gives me a mistake. Coefficients are not defined for boosted type GB3. It's about coefficient. Coef is not used during training. Okay, feature importance, it works. Uh, as for feature names in define when it has feature names that are all strings. Okay, I can get my information about my model, my rounds. I can get params. It's more of readable than, but it's okay. They are nearly the same, but they differ. Um, GB params and get params. They differ. Okay, who gets an error and is not defined for boosted type. Again, this error. Okay, I can save. I can load. I can features number of features again. I can get score one. Ah, not one. But why it was one before? Something changed. Okay, so difference. So predict probe. It's predict the probability of each example being of a given class. So it gives not the number. It gives the probability of each class. So here is class number 2 because it has the biggest probability. So another is set params. It's okay. Modification of the scalar method to allow unknown quarks. Allow unknown quarks. Okay, this allows you using the full range of XGBoost parameters that are not defined as member variables in scalar grid search. And a link to some examples. So, big material, much to learn is my first steps. Okay, thank you for watching. Who could? It's for my education and maybe it will help somebody. Okay, thank you very much. Bye.